Hello friends. Today we are going to discuss the next practical application of the friction, that is ladder friction. As you know, we are using ladder for different practical applications like climbing of the buildings in garages, workshops, etc. Okay. Now ladder, suppose this is a vertical surface and this is a horizontal surface. The ladder is always inclined. Ladder moves in the downward direction. Means what? When this point B moves to the right and A moves downwards. So how the forces will act? You see, this is the motion. Point B moves to the right and point A moves downwards. Normal reactions, you see, ladder, both surfaces consider they are rough surfaces. So normal reaction at point B will be NB, normal reaction at A will be NA. But frictional forces will be opposite. When B moves to the right, friction will be to the left but parallel to horizontal surface. Here also vertical surface, ladder, this point P moves downwards, and that's why frictional force will be upwards but parallel to this surface. When ladder moves upward direction, suppose point A moves up and B moves to the left, this is the motion, this is the direction of motion. Only normal reactions will not change in previous case and this case, they will remain as it is. Only direction of frictional force will change. Previously it was to the left, now it is to the right. It was upward, now it is downward. This concept should be very clear to you. Let us take a very simple example of a ladder having weight 196 Newton. Total length of the ladder is 4 meters. So self weight will be acting at a half distance, 2 meter from top and 2 meter from bottom. Now 196 Newton resting against a rough wall and a rough floor, means horizontal surface is also rough, wall is also rough. Calculate the minimum horizontal force be required to apply at point C in order to push the ladder towards the wall. Assume MUS at A is 0.3 floor and wall is 0.2. Okay. So we want to push the ladder towards the wall, means point A will move to the left and B will move upwards. So these cases we have discussed. Okay. So normal reactions at A will be NA, B will be NB, perpendicular to the surface, and self weight will be acting downwards, and P we have applied. That value we want to calculate. When we want to push this point A to the left, friction will be acting to the right. When A will move to the right, B will move upwards, and that's why frictional force will be downwards. Frictional force value at B is mu n, mu B and B, and at A will be Fa will be mu A Na. So this is the ABD. You should be in a position to draw this correct ABD as per the statement of the numerical problem. Okay. Now you see, if you find out the distances, horizontal distances will be cos of theta and vertical will be sine of theta. So if you take fx will be what? F summation of horizontal forces, fa to the right plus nb minus p. You see, fa plus nb minus p equal to 0. This is summation of horizontal forces. Rest fa is what? Mu a na, that you can substitute. Now fy will be you see, na minus 196 minus fb. So minus fb plus na minus 196 equal to 0. Simply upward positive, downward negative, you will get fy. Substitute the value of fb, mu b and b. This you will get second equation. Now let us take moment at point A. If you take moment at point A, then what? How we will take the moment? Moment of these two forces will become 0 at A because they are passing through the same point. So first let us take NB. How it will give moment? Clockwise about point A. And what is the distance? Vertical distance. Vertical distance is how much? 4 sine theta. So minus NB into 4 sine theta. Next is frictional force at point B. Frictional force at point B. This is frictional force. FB is what? Mu B and B. How it will give moment at point A? If you take it like this, anti-clockwise. So this will be mu B NB into horizontal distance 4 cos theta. Next is 196 is a weight into, it is acting at the center, and that's why the distance will be 2 cos theta. It is giving anti-clockwise, that's why positive. Plus P, how it will give moment at A? Anti-clockwise. Plus P into you see this distance is 1, and that's why 1 sine theta. Vertical distance we want, this vertical distance, that is from P, the vertical distance is 1 sine theta equal to 0. So you will get equation number 1, 2 and 3. These 3. Solve 1, 2, 3. You will get P 239.95 Newton. You will get normal reaction at A 230.18 Newton. Normal reaction at B is 170.9 Newton. This way you can solve the problems. We'll solve some more problems on ladder so that you will get more practice on the problems of ladder. So with this today we'll stop. Thank you very much.